And welcome to another Hopper on 6502 video. I'm going to cut straight to the demo here. It involves this little OLED display. So let's build and let's launch into the debugger. There we go. It's generating code, disassembling, launching into the debugger. Takes a little while to upload. There we go. Uploading the program. And let's run the demo. A little bit slow. So I was inspired by Anders Nielsen's device. He's got this device, which is his what does he call it? 6.5 Ueno, that thing. And he got he bit banged I2C on two pins of his riot chip to get his OLED display working. So I started from his code and used his driver to create one for the Hopper minimal runtime. So the Hopper minimal runtime, there's a lot of devices and displays that I've written Hopper drivers for. So all these different screens, and the Hopper runtime library has a lot of stuff in it that was written to work on, well, I was working on the Raspberry Pi Pico devices, the microcontroller devices. So I wanted to see if I can bring some of this stuff to the minimal runtime and get them running on the 8-bit microprocessors again. So using Anders Nielsen's work, I added to, so there's an MCU for the minimal runtime. It's an MCU unit. And in it, there's the usual things you'd expect from like Arduino style pin. But on the 6502, they're really just memory access because the memory is mapped to the I/O. But to get the bit banging for the I2C to work, I actually had to write it in assembly because it has to be fast enough. And that's what Arduino calls the wire library. So the wire unit in the Hopper, I created the minimal runtime for it, and it's only got 3 APIs right now. So, you know, begin transaction, write a byte, and end the transaction. And it's quite slow because I mimic these, you know, writing a whole data array is looping through Hopper to do it. If this was a native call, it would be a little bit faster, so the whole display thing would get a little bit faster. But anyway, it's good progress because it now means I mean, right now I'm only writing to I2C, so I need to test the read byte as well. But what it means is we can add more I2C devices to the 8-bit microprocessors now. For example, things like real-time clocks, or the one I'm really interested in adding is a serial EEPROM, so that when you upload your program, it can persist. Yeah. Anyway, there you go, in addition to the minimal runtime for the 8-bit microprocessors, specifically the 6502. Now we've got I2C on it. Thanks, Anders.